In this video, we're doing page 3 on the review worksheet, starting with number 11, using the table provided below, which shows f of x is a continuous function. First, we have to prove that the function will equal -10 for some x values. So, just to review, a continuous function means that it can be drawn without picking up your pencil. So if we focus in on these first 2 points on the function and mainly look at their y values, it goes from -12 to 1. So -12 is a negative value. It's continuous, so we could draw it without picking up our pencil and somehow get to a y value of 1. And we're trying to prove that it will hit a y value of -10. So think from -12 to 1, -10 is on that interval. And it's going to hit every x value and y value in between. Every x value between 0 and 2, every y value from -12 to 1, since it is continuous. And what we learned was the rule is it's all because of that intermediate value theorem. So that's what we're going to use to prove that the function will equal -10. So in order to do that, you should write out the sentence. We practiced this in our notes. We said, since f of x is continuous, you must state it's continuous, and then state these 2 points that you know. Since f of x is continuous, f of 0 equals -12, and f of 2 equals 1. Since all that is true, we can say by the intermediate value theorem, our function must equal -10, because again, that's between -12 and 1. So we could say by the intermediate value theorem, f of x must equal -10 for some x value, say some x value that we're going to call c, and that's all we have to say. All right, remember, you must say the following. It is important to include that we know our function is continuous, name those 2 points, and that's really your info that you need to know, and then we can apply that intermediate value theorem. Because -10 is between -12 and 1, we know it will be hit, because the intermediate value theorem, IVT, says that every x value and every y value will be hit as long as a continuous function, as long as it's continuous. All right, part B, it says, state the smallest interval where C must occur. And actually, it's right here. From -12 to 1, that's where that -10 would fall. So really, these other values are not important. So I would just say the smallest interval, and they're talking about x intervals, is from 0 to 2. If we're looking for an x value, it's going to be somewhere between 0 and 2 that our f of x will be equal to -10. So I would just say that smallest interval is from 0 to 2. And I would use parentheses because it's definitely not at 0 or 2 where it's hitting -10. It has to be somewhere in between. All right, for number 12, it says, list the points from the graph provided to the right from least to greatest based on their derivative. So here I would start drawing tangent lines at these. It's probably easiest if you use some sort of straight edge. Remember, a tangent line should only touch the graph at 1 point. So maybe something like this would be the tangent line at A. In part B, something like that. Part C, that one probably goes underneath. Something like that. D, looks like that's going to have a slope of 0. And then E is the last one. That looks like it's going to be somewhat of a positive slope right there. All right, so we need to rank these. And it said from least to greatest over here. If you look, least to greatest, so think negative slopes should come first, then 0, and then the greatest should be the positive slopes. So let's start with negative slopes. Any negative lines, that's going to happen at B and C. And think, which one is more negative? To me, B looks like a flatter line. Flat lines are closer to 0, And then C looks like it's a little bit steeper. So I think that C, since it's a little bit more vertical there, that's going to be our most negative slope. So C is going to come first. All right, then B seems like it has a negative slope, but it's slightly less negative. It's more of a flat line. B. E, I think that should have been a horizontal line. Mine kind of ended up being a little bit positive, but even it's pretty close to 0. If you look at the other slopes, they're a little bit more steep, a little more vertical. So I think E would come next. And then kind of just keep thinking, which one's the next one? I would say yellow is the next line, and then A is the most steep, the most vertical. So the yellow was at point D, and A has the greatest slope, it's the most vertical. That's how I would go about that. The next one. In the graph that's to the right, provide a sketch of the following functions that meet this criteria. So hopefully you guys know that f of 2 equals 3 just means the point 2, 3 has to be on the graph. So let's take care of that first. Over 2, up 3. That point has to be on our graph. And we're supposed to be graphing f of x, sketch of the function. So I don't know why it doesn't say it in the directions, but we're supposed to be graphing f of x, not the derivative. But they do give you information about the derivative. We have to remember these rules, that when the derivative is greater than 0, that means our original function, f of x, is increasing. So f of x is increasing when x is less than 2, or to the left of 2. If the derivative is less than 0, that means your original function, f of x, is decreasing for x values greater than 2 or to the right of 2. All right, and then the last thing it says, the derivative equals 0 when x equals 2. So that means if the derivative equals 0, the slope of the tangent line is 0, or your original function, f of x, has either a max or a min. It's going to be one of those. So think at x equals 2, basically that point that we drew in over here, that is going to be either a max or a min. So let's go back and say, we know f of x is increasing for x values less than 2. So to the left of 2, we have to be increasing. So how about something like this? Should work for x values to the left of 2. If I trace it from left to right, my pen is going up. That's increasing. Then we said for x values greater than 2 or to the right of 2, our function should be decreasing or going down. Maybe something like that. We got that. And then the last one takes care of itself. At x equals 2, it's a max or a min. Right here, this point is a max. So we got that down too. So that is a good function if we were drawing f of x. Again, that's the original function, not the derivative. I'm going to keep going to the last page. Here, they give you a function s of t. They say it's a position function for an object at any time on the interval -2 to 3. They say find the average velocity. We said average velocity is really just slope. All right, so think your slope formula is y2 minus y1 over x2 minus x1. Another way to write that, these are our x values here. To find the y values, we got to plug them in. So just another way to write it, we could say we have to plug in s of 3. We're going to subtract s of 2. If you plug in your x values into s, we'll find those y values all over the x values 3. Oh wait, and that was a -2. I'm sorry. Plug in -2. And on the bottom, 3 minus a -2. So we need to plug those values in. I'm going to do it off to the side, or maybe even below. S of 3, if we plug that in, -3 to the third power, plus 5 times 3 plus 6. If we do that work, we should get -27 plus 15 plus 6. If we add these, it's going to be -27 plus 21, or -6. So we at least know S of 3 is negative 6. We could plug that in later. Then we also have to find S of negative 2. If we plug that in, negative times negative 2 to the third power plus 5 times negative 2 plus 6 equals negative 2 to the third is negative 8 times a negative is positive 8. This gets you negative 10 plus 6. 8 minus 10 is negative 2, and negative 2 plus 6 is 4. All right, so we at least know those values. Our S of 3, we said, is negative 6. Let's plug that in. It was minus our S of negative 2 value, which we said is 4. All over on the bottom, a double negative turns positive, and that's 5. So we get negative 10 over 5, or negative 2, is our average velocity there. Part B says, what is the instantaneous velocity? We said instantaneous velocity at a certain time, that's the same thing as the derivative at that time or the slope of the tangent line. So you could do that limit equation, that's the longer way, but remember, if that's the same thing as the derivative at t equals 2, we could probably just do the power rule that we learned to find the derivative of S of t, then plug in 2, and that would be our answer. I think that's a shortcut. So let's find the derivative of S of t. If we do that, bring the 3 out in front, we'd get negative 3t squared plus 5. Remember, a constant just goes away. So that's our derivative. We could plug in 2 to that. Negative 3 times 2 squared plus 5. We're going to get negative 3 times 4 plus 5, which is negative 12 plus 5, which is negative 7. All right, so that is going to be your instantaneous velocity there. Moving on, the bottom. Use the graph of f of x to estimate the following. All right, this is the graph of f of x. F of 4 means we're just looking for the point on the graph. They gave us the x, we're looking for the y. So let's find f of 4, follow it up, do our best. To me, this looks like f of 4. Looks like it would be the point 4, 5. All right, now we're supposed to estimate the derivative at 4. So this is the graph of f of x. The derivative means the slope of the tangent line at 4. So let's draw that tangent line in, do our best. I might try to make it as long as possible, just so it's easier to estimate the slope of that. Remember, slope of the tangent line is really what we're looking for. Let's think about rise over run, maybe to go from this point to, let's say, that one. It's about down 8 over 1, 2, 3, 4, 5. We'll estimate right there, down 8 over 5, negative 8/5. Again, it's an estimation. It might not be perfect, but somewhere around there. All right, so I'm going to estimate negative 8/5. So we have the point on that graph, that point of tangency that we just found right here. We said that was 4, 5. We found the slope of the tangent line over here. And now they want the equation of the tangent line at x equals 4. We got our point. We know the slope. I'd be thinking point slope form. It's going to be y minus 5 equals our slope, negative 8/5, times the quantity x minus 4. That would be the equation of the tangent line. Again, yours could be different if you just estimated the slope differently. And then it says, use your equation in part C to approximate f of 6. Remember, if you don't have the function f of f, or f of 6, we don't have that function f, we don't have it to plug in. We could look at the graph, but a good approximation is just plugging it into the tangent line. So I might do some work here with this tangent line. I might put it in y equals mx plus b first, if we just copy it. Y minus 5 equals negative 8/5. X plus 8 times 4 is 32 over 5. We could even make that a fraction. Get 32 over 5 there. And then we could add this 5 to both sides. So think y equals negative 8/5 x plus 32 over 5 plus, if I want to add these, I need a common denominator. So think, how do we rewrite 5 with a common denominator of 5? 5 times 5 is 25. Hopefully you guys agree. 25 divided by 5 is the same thing as 5. All right, but if we rewrite that, we get negative 8/5 x plus, if we add these together, we get 57 over 5. Again, that was just rewriting the equation of the tangent line, which just helps if you want to plug in an x value. It helps if you rewrite it in y equals mx plus b. So I would say that f of 6 is about negative 8/5 times, instead of x, let's plug in 6 plus 57 over 5. All right, and if we do this math, 8 times 6 is 48, so that's negative 48 over 5 plus 57 over 5, and that is 9/5 that you get, which is also the same thing as 1 4/5. So let's just kind of see how our estimation went. We can look on the graph at f of 6 and think, is it about 1 4/5? That's almost about 2. Let's take a look at that. Remember, we have the graph of f of x in front of us, so we can actually get the exact answer. F of 6, to me, does look like it's about 2, maybe a little less there. So a little bit under 2, that should make sense that 1 4/5 is our estimate. All right, so that would be the answer. I was just comparing it to the graph to see how close I was. I hope this review helped you guys. Good luck on the quiz tomorrow.